In this video, we're going to go through the chapter on data visualization from the book R for Data Science. This is part of the section called Whole Game, where we're going to be focusing on big picture tools when it comes to working with data in R, including importing, tidying, transforming, and visualizing your data. And we're all doing this in a broad overview to just give us a taste of that full process. Later, you can see in the book, we're going to go into more details on these individual topics. Now, we're starting with visualization, which is a little counterintuitive. Typically, you would start with importing and tidying your data. But the reason they're starting with visualization is just because it's one of the most fun things you can do with your data, and therefore it's very motivating. So it's just a good place to get started. And there's plenty of sample data sets that are built into R that we can use to visualize. And then later, we'll rewind and we'll talk about importing and tidying your own data. So with our end goal in mind, let's dig into data visualization. And the first thing we learn is we're going to be using an R package called ggplot2. Technically, we could create visualizations just using built-in R functionality, but ggplot2 is ubiquitous in data science in general. It's used in lots of places and it's very sophisticated. It provides a lot of additional functionality and just an easier way of generating visualizations than base R functionality. So that's why we're going to be starting with it. In order to use ggplot2, under the prerequisites, we see the information on how to make sure it's installed and loaded in our current RStudio session. We went over these details in the precursor video when we went through the introduction, but if you're just joining us, what you're going to want to do is make sure you've run the command install that package's tidyverse. In RStudio, you'll want to run that in the console at your prompt, and that's going to download the software for the tidyverse library of packages, which includes ggplot2. In my case, I've already done that, so I'm not going to run that command, but I am going to run this command library tidyverse. This is just going to make sure that the tidyverse family of packages is loaded in my current R session. So let's bring that into RStudio. Let's run that. And in my case, it looks like I had already run that command previously, so everything was loaded. If it wasn't loaded, I would see output similar to what they're showing in the book, where it's telling you what packages are loaded, and you should see ggplot2 listed there. Beyond ggplot, two additional packages we're going to be using in this chapter are Palmer penguins. This is where we're going to get an example data set we're going to work with, and ggthemes, which just provides a additional color theme we can use when generating our visualizations. Like tidyverse, these packages should have already been installed when you went through the introduction, so we should just be able to run these library commands. And now we're good to go to jump in with our first example, which, returning to the book in section 1.2, first steps, we learned that we're going to be working with an example data frame called penguins that comes from that Palmer penguins library that we just imported. This data frame includes information collected from 3 species of penguins living in Antarctica. And we're going to use this data to try to answer some of the questions that are posed in this introduction, such as, do penguins with longer flippers weigh more or less than penguins with shorter flippers, etc. You can read through all the questions that are posed. And then we learned that the way we're going to answer these questions is by creating visualizations. Before we get to the visualizations, though, we have to familiarize ourselves with the data that we're going to be working with. And we also want to talk about what a data frame is, because a data frame is a core structure that you're going to encounter when we're working with R. So this is a really good place to get started. And what I'm going to do, going back to RStudio, I want to take a look at the penguins data set that comes with Palmer penguins. There's lots of different ways to do this, but the way I'm going to start off is using the view method. So that's capital V, view. And then in parentheses, I'm going to pass the name of the data frame that I want to load, which again, in this case, is just penguins. So as you can see, that brought up this special view pane in RStudio where we can see the contents of this data frame, which is just a typical spreadsheet-like rectangular collection of data where we have rows and we have columns. The columns contained our variables for our data, such as species, island, bill length and millimeter, etc. And then each row represents a single observation. And in this case, that's going to be an observation for a single penguin. At the intersection of these rows and columns are our values. For example, if we look at this value here of 3,750, we would say that this is the value for the first observation for the variable body mass G. Another approach to familiarizing ourselves with a data frame is, instead of using the view function, we can simply just reference that data frame in the console prompt, which once we open up the view pane, you'll notice the console got bumped down to here. Here is our prompt. And like I said, we're just going to reference the penguins data frame, and I'll hit enter. And we're going to get a nice snapshot of this data frame. In this example, this snapshot includes just the first 10 rows or observations, just to give us a general feel for the data. Just like in our view output, we can see the different variables or columns via this header information here. And then below that, we have some meta information about the data type for each of these particular variables. We'll be looking closer at data types further along in this book, so I'm not going to break this down. The key takeaway here is just this idea that what we're seeing is a summary of this data, and it's a quick and easy way just to familiarize ourselves with what we're working with. Now, a quick note in this output, rather than describing this as a data frame, it's actually describing it as something called a tibble. A tibble is a special data structure we get with tidyverse packages, and it's basically just an enhanced version of R's base data frame. There are differences between a tibble and a data frame, but for our purposes, they are effectively the same. And so as we work through the beginning sections of this book, you might see the terms data frame and tibble used interchangeably. The last step we're going to take in familiarizing ourselves with our Penguins data frame is we want to pull up the documentation for it. The way we're going to do that is in the console prompt, we're going to start with a question mark, followed by the thing we want to get the documentation for, which in this case is Penguins. And keep this technique in mind because you're going to use it a lot when learning about R functionality, because you can do it with pretty much anything with R. You just run question mark followed by whatever package name or function or object you want to learn more about. And if help documentation exists for it, it's going to load it. So let me go ahead and run that. And where we're going to see the documentation is over on the right in the help pane. So here we can learn more about this data set, and we can see its size measurements for adult foraging penguins near Palmer Station, Antarctica. Here's a more detailed description. There's not much under usage notes because this is just an object of data, so basically the only thing we can do is reference it. If this was documentation for an R method or function, we would see a lot more information here. And then under format, we see basically a breakdown of some of the things we already saw when outputting the data frame and looking at it in the view pane. We can see the different variables that this data frame contains. And then we actually see more details about those variables so we can get a better sense of what kind of values they're actually storing. So now that we're familiar with our data and the idea of a data frame structure in R, let's check back in and see what our next steps are. So we're now under section 1.2.2 ultimate goal, and we're told that what we want to do is we want to create this visualization, which displays the relationship between flipper lengths and body masses, taking into consideration the species of the penguin. So to get started with this visualization, scrolling down to section 1.2.3, it gives us a starting line of code. We're going to reference the ggplot method, which comes from that ggplot2 library that we've already loaded in our session. And the first argument we're going to pass this method is what data we want to be creating a plot for. And in this case, it's going to be penguins. So let's go ahead and copy this code, bring it into RStudio. I'm going to paste it into the console, hit enter. And you can see it switched me from the help pane over to the plots pane where any of my visualizations are going to appear. And right now we just see an empty gray box because we need to provide ggplot with more information to really start creating a plot. It's not enough to just tell it the data that we want to plot. We got to tell it what to do with that data. The way we're going to do that is by building on this example. So what I'm going to do is I'm going to hit the up arrow, and that's going to cycle through previously run commands. So I'm going to just bring back the last command I ran, and then I'm going to add another argument. I'm going to separate my arguments with a comma. And this second argument is called mapping because we're going to be indicating how we want to map the data to this plot. The way we're going to indicate mapping is by invoking a ggplot function called aesthetic, or AES for short. And we're going to give it two values, what we want to map to the x-axis and what we want to map to the y-axis. So for the x-axis, we want to map our flipper length variable. And the y-axis, we want to map our body mass G variable. And let's go ahead and run that. And there is some good forward progress on our plot. We can see our different axes were labeled with the variables we're going to be mapping to them, and they were set with the appropriate scale. But we're not yet seeing any observations because there's one more step we need to take. And once again, in the console, I'm just going to use the up arrow to bring back the previous run command so I can add on to this. And what I'm going to add on is a layer. So ggplot works a lot with this idea of layers where you can basically layer onto your plot. And what we want to layer onto this plot is our observations. And we're going to indicate how we want those observations to be displayed using a geometric object. The syntax for that is going to look like this. We're going to use the plus sign, and then I'm going to start to reference geom. And what you'll notice in RStudio is it's going to try to autocomplete with one of the numerous geom objects that exist in ggplot. Right, so each of these geoms or geometric objects represents basically a different plot type. And what we want to do is create a basic scatter plot, and we're going to find that under the geom called point. So I'm just scrolling down, geom point, and we can see some information about this. It says the point geom is used to create scatter plots. So let's go with that. And we can add some customizations to this eventually, but for now, let's just go with a bare bones scatter plot. So I'm going to hit enter. And there we go. Finally, we're able to see our data. And returning to the question we posed earlier of, is there a relationship to flipper length and body mass? It appears we've got a positive correlation here, and it's pretty linear, right? So as flipper length increases, so does body mass. Before we continue to expand on this plot, I want to draw our attention to the warning message that appeared when we ran this last command. It tells us that it removed 2 rows containing missing values or values outside the scale range. And this occurred because if we look at our data, we could see things like row number 4 for bill length and body mass. It says NA, which is short for not available. And logically, when ggplot encounters rows like that, it can't plot that data if it doesn't actually exist. So we see a warning message like this. Now, dealing with missing data is a whole topic unto itself and something we'll talk about later in this book when we get further into the tidying and transforming process of working with our data. But for now, we're just going to make note of the message and observe what it means and continue on. And what we want to continue on with next is we want to add a third variable to our plot, which is the species of the penguin. The way we're going to accomplish that, once again, I'll hit the up arrow to bring back our command. I'm going to go back to the aesthetic function. And in addition to mapping data to the X and Y axes, I want to also map data by color. So I'm going to add a third argument here called color. And what I want to be represented by different colors is going to be our species of penguins. So let's run that. And there are our results. Our dots are now color-coded according to species, and a legend was added to our plot. All right, so when you're dealing with categorical variables like species, and you map them in this way, ggplot does a process known as scaling, where it's going to assign a unique color to each of the levels in your categorical variable. So in this case, that's going to be our 3 species. Next up, to further visualize the relationship between flipper length and body mass, let's add another geometric layer to this chart. So once again, I'm going to hit the up arrow to bring up my previous command, use the plus sign, and this time instead of geom point, we're going to add something called geom smooth. This is going to create a curved line on our plot, and the argument we're going to pass this is method, and we're going to set it to be LM, which is short for linear model. So this is going to draw a line of best fit based on a linear model. So you can see the end results there, but this isn't quite what we're looking for, especially if we think back to our end goal for this plot. What happened here is it drew a line for each of our individual species. And the reason that happened is because when we mapped color and species, we did it at essentially the global level of this plot. So this mapping got passed down to each of our subsequent layers, including the geom points and the geom smooth, which we don't want. We really just want the mapping of colors and species to happen at the geom point level. So what we're going to do is we're going to move this mapping from this global level to the local level, targeting it specifically in the geom point layer. Let me show you what I mean. So let's bring back the previous command, and we're going to add a mapping argument to geom point. Once again, we're going to use the aesthetic function, and we're going to say color is species. And then we can get rid of that mapping at the global level. So let's run that. And there we go. That's closer to what we're looking for. Now, before I proceed with this plot, I want to bring up my previous command. And I want to address the fact that this command is starting to get very long, and it's a little hard to read. It'd be much easier if we added some line breaks in between each of our layers. In fact, if you're following along in the book, you'll notice that all the code samples they provide are formatted in this way. All right, so here's our initial call to ggplot, then we see the plus sign, and then each subsequent layer is on its own line, and overall it's just more legible. The way we can make this happen as we've been manually typing commands in the console is let's put our cursor where we want a line break, and we're not going to just hit enter because that would just run the command. Instead, we're going to hold down shift and then hit enter, and that's going to give us that line break. So we're going to do it after that plus sign and also after this plus sign, shift enter. And we can go ahead and run that again just to make sure it didn't cause any errors with that formatting, and we could see it's producing the same plot. So not necessary, but like I said, just makes the code a little bit easier to read, especially as we continue to add features to this plot. And speaking of adding features, let's adjust this plot so it's accessible to people with color vision deficiencies by also mapping our species by shape. So let's bring up our previous command, return to the aesthetic mapping in geoPoint, and we're going to add shape as an argument. And just like with color, we're going to map this to species. And there we go. We can see that the Adelie penguin was mapped to a circle, the chin strap to a triangle, and the gentoo to a square. For our finishing touches on this plot, let's add some better labels. And for this, I am going to go back to the book and copy the code that they provide just because it's a little verbose. So here's what we're going to be adding. We're going to be adding a labels layer. This is accomplished using ggplot's labs method. And most of the arguments passed here are pretty self-explanatory. So this is going to be the title of our plot. We're going to add a subtitle. We're going to label our X and Y axes. And we're also going to tweak the label of the legend itself so it capitalizes species. And then finally, we're going to optimize the color palette used for our species mapping by adding the scale color colorblind layer. This comes from the GG themes package we included at the beginning of this exercise. So let's copy all of this, bring it into our studio, run it. And there we go. We end up with a plot that looks like the screenshot of the initial goal we set out with at the beginning of this exercise. Now, before we proceed forward in the rest of this chapter, I want to highlight that in this example, a lot of things were thrown at you, right? A lot of new methods and arguments. You might not even know what a method and argument is yet if you're especially new to programming. And I want to just recognize that and highlight that the point of this exercise was really just to give you this broad overview and start to get a sense of what you can do in R and in packages like ggplot2. All of the details of, well, how do we know what the arguments are? How do we know what functions to use? These are all things that are going to come with time. And one of the things you can do now to start to familiarize yourself with these things is take advantage of that help feature I showed earlier. So for example, if we do just question mark and ggplot, we can learn more about this ggplot function. So here we see a description. We see example usage of the function, which maps what we saw. So we started by passing it a data argument, followed by a mapping argument. And then for each of the arguments, it tells us what that argument does and what sort of information it's expecting. And we could do this for any of the other methods we encountered as well. Let's say we want to learn more about what options we have for labels. We can just do question mark labs. And we've got lots of details that we could dig through and learn about all the different arguments and options that are available. Moving forward, returning to the book and scrolling down, the next section is a series of exercises that you can work through that has you thinking a little bit harder about the penguins data set and also generating some additional plots. So I encourage you to take the time to look through these exercises and try your hand at them. And then in the description to this video, I'll include a link to the solutions for these exercises if you want to check your work. But we're going to skip over that. We're going to go to section 1.3, ggplot2 calls. And here they're discussing different styles for specifying your argument values when invoking a function. And in all of the examples they've provided so far, they've been very explicit in how they specify the arguments, right? When we specified the data argument for ggplot, we literally said data equals penguins. Same thing for mapping. We said mapping equals, and then we pass it the aesthetic. Now, this indicating of the argument name itself is actually optional. The other way we could have written this is we could just pass the data value as the first argument to this function, and then pass the mapping argument as the second value to the function. So we're not explicitly saying data equals penguins, mapping equals aesthetic. It's just assumed based on the order in which we're passing these arguments, which again, if we go back to the documentation, I'm going to bring up the ggplot documentation. We can see that the first two arguments for this function are data and mapping. So if we don't explicitly indicate it's data and mapping, it's just going to take whatever we give it as the first and second argument as data and mapping. And this pattern of excluding the argument name, especially for the most commonly used arguments, which is usually the first 1 to 2, maybe sometimes 3 arguments, is very common. We write things more concisely just because it's pretty much always assume that if you're invoking ggplot, the first two things you're going to give it are data and mapping. So we can just intuitively understand that that's what this information is without being very explicit. Now, they chose to be explicit in these beginner examples just because it's helpful as we're getting familiar with these functions to understand what the arguments are. But as you get more comfortable with things, you can leave that out, and it's definitely something you're going to see as you're encountering examples in other people's code. So basically, this section is just a little aside on code style. So let's plow forward and go to 1.4, Visualizing Distributions. Here, we're going to learn how to create bar charts for categorical or numerical variables. So starting with categorical variables, we're going to be plotting the species variable of our penguins data set. Let's go ahead and run this code. And just because we're moving on to a next section, let's clean up a little bit. Let's close our penguins view. Let's click the broom icon to clear our console. And then I'll paste in the example code. And just like we saw in the book, here is the end result. Building on this example, they show us how if we wanted to order the species by the frequency, the way we could do that is we're going to wrap the species in a function called factinfreq, and that's spelled FCT_INFREQ. And the FCT is short for factor, which is a data type used in R to encode categorical variables. And we're saying we're going to be ordering our categorical variables in frequency or by frequency. In other words, by the number of observation within each level. And that yields us our bar chart nicely reorganized by frequency. Looking beyond categorical variables, we can also create charts for numerical variables, such as the body mass of the penguin. So let's work something up there. We're going to say ggplot penguins. And then our aesthetic, what we want to map to the x-axis is going to be body mass G. And then our geom layer, this time instead of geom bar, is going to be geom histogram. And an argument we can pass to this is the width of each bin in the histogram. So let's set this to be 200. Looks like I have a typo there, so let me hit the up arrow again and just fix that. And there you can see the end results with our bin width of 200. And let's just play around with different bin widths just to see how that impacts our graph. So if we set it to a lower number like 20, that ends up yielding a lot of bars, which just makes it difficult to really get a grasp of the shape of this distribution. Similarly, if we go with a larger number, let's say 2000, we end up with all the data being binned into only 3 bars, and that really obscures the shape of the distribution. So it's all about finding the balance there that makes sense for your data. And let's go ahead and set ours back to 200. Another way we can map our numerical distributions instead of a histogram is a density plot. And so for that, we're just going to swap out geom histogram with geom density. And that yields us a nice density curve of our data. Moving on from these examples of visualizing distributions, let's talk about visualizing relationships. For this, we can use a box plot. So let's do ggplot of our penguins data. And for the aesthetic, on the x-axis, let's do species. And we want to see the relationship of that to the body mass of the penguin. So for our y-axis, we'll set this to body mass. And like I said, we're going to use a box plot here. So that's going to be geom box plot. And here are our resulting box plots where, just as a refresher, the box itself represents the middle 50% of the data. So from the first to the third quartile, or the interquartile range. The line inside the box represents the median. The lines extending outside the box represent the min and max within 1.5 times the interquartile range. And then finally, any dots represent outliers or unusually low or high values. Another way we could visualize this information is using that geom density function again. So what we'll do this time is we're going to plot our penguins data. And for the aesthetic, on the x-axis, we want to have the body mass. And then we'll do species by color. And again, we're using the geom density function. And you can see we've got 3 density lines, each color-coded by species. To make this a little bit more visually compelling, let's rerun that and let's add another mapping. In addition to color, let's map the species to the fill attribute. And this is going to fill our curves with a solid color. So to make sure we can see all of them, let's add a alpha attribute to our geom density plot, and we're going to set it to be 0.5. So basically half transparent. And there's our final density plot looking at the relationship between body mass and species. Moving on from this example that shows the relationship between a numerical variable and a categorical variable, let's now look at the visualization for two categorical variables. And the variables we're going to be looking at, let's bring back our penguins snapshot. We're going to again use species, and we want to look at the relationship of species to our island variable. So let's work up a plot for this, and what we're going to create is a stacked bar chart. We're going to set the x-axis to be our island variable, and the species is going to be mapped to the fill of each of our bars. And of course, let's not forget to set our geom. In this case, it's going to be geom bar. And from this resulting chart, we get a sense of the distribution of species across islands. We can see there's roughly an equal amount of the Adelie penguins across the 3 different islands, whereas we only see the Gentoo penguin on the Biscoe Island, and we only see the chinstrap penguin on the Dream Island. If we wanted to get a better sense of the percentage distributions across the islands for the different species, we can modify our bar chart and add an attribute position, and we're going to set this to be fill. So now you can see our scale is out of 1 or 100%, and we can very easily see the relative frequency of the different species. So on Biscoe, Gentoo penguins make up roughly 75% of the population, with the remaining percentage taken up by the Adelie penguins. With the Dream Island, roughly 50% is chinstrap penguins, and then Torgenson, 100% of the penguins there are the Adelie species. Checking back in with the book, we are still in section 1.5, visualizing relationships, and we just went through subsection 1.5.2, where we looked at 2 categorical variables with our bar chart. The next subsection 1.53 looks at 2 numerical variables, and this is just similar to the first example we looked at where we created a scatter plot. So I'm not going to go through that again. If you want to look at this code, revisit it, you'll find it under this section. Let's go ahead and jump into subsection 1.54, where we're going to see how we can plot 3 or more variables. The first approach they show to do this is we're creating a scatter plot, and instead of mapping species to both color and shape, we're going to introduce our third variable to shape. So for shape, we're going to set that to island. And here's what that resulting plot would look like. And they make the point in the text here that this is basically too much information jammed into one plot. It's cluttered and it's difficult to wrap our brains around. So as an alternative to this, we can essentially break this into separate subplots or facets. The way we're going to accomplish that is using a ggplot2 function called facet wrap. And let's go ahead and copy this code example and actually run it. So the end result is we have 3 separate subplots or facets, 1 for each island. And then within each of the subplots, we can see the distribution of species by shape and color. Breaking down the code, we can see that for the x-axis, we are going to be indicating flipper length. So we see that down here. For the y-axis, it's going to be body mass. So we see that here. We're using the geom point function to create the scatter plot, and both color and shape are mapped to species. And then the third variable, island, comes in with this facet wrap function. So we're basically saying create a unique subplot for each island. And the argument that facet wrap is expecting is a formula, which we indicate with this tilde character. And that's a little syntax intricacy. We'll get into more details later. So let's not get too concerned about that right now. Just remember the big picture again is we're creating individual subplots for each of the unique values within our island variable. And with that, that's the last plot we're going to generate in this chapter. Obviously, there's more we can talk about when it comes to visualizations, and there's going to be a more detailed chapter of it coming up. But remember, the point of this particular section was really just to get us inspired and start to get a taste of some of the things that we can do in R using packages like ggplot2. Now, to wrap things up, if we jump down to section 1.6, there's details on how you could export your plots. And there's lots of different ways you could go about this. You may have noticed as we've been working in RStudio and looking at our plots, there's actually an export menu. So you could do it from the menu options, or if you want to do it programmatically, we can use the ggsave function that comes as part of the ggplot2 package. And let's go ahead and copy this example from the notes and just run it. What this is going to save is your most recently generated plot. For the file name, you can indicate a file name you want, and we're going to give it a .ping extension because that's the default file format we're going to get when we use ggsave. So if I run that, we get confirmation that an image was saved, and it tells us the dimensions of that image. We get the same warning message about the missing rows we've been seeing all along, so we can just ignore that. And then in terms of where this file was saved, it's going to save to what is referred to as our working directory, which is like our active directory. So anytime we do things like import data files, or in this case, generate and save images, it's always going to be relative to that working directory. And to see, or one way to see what your working directory is set to, if we go over to the Files pane, click the More icon, then click the option Go to Working Directory, it'll take you to whatever your current working directory is. And depending on how you opened RStudio and first started this example, your working directory might be different than mine. I've actually got a project set up here, so I had created a subfolder for this example. But long story short, wherever your working directory is, that's where you should see the resulting image that we just created. And sure enough, in my directory listing here, you can see penguinplot.ping. And if I click on it, there is the resulting image file. And of course, if I wanted to access this outside of RStudio, I would just navigate to whatever directory it shows as my current working directory using things like my File Explorer, and I should see that image file there. So there's lots more you can do in terms of customizing how you're exporting and saving your plots, and we'll get to that further. They also mention generating final reports with your plots using Quarto, and that's something in the latter part of this book under the Communicate section we'll talk about in more detail. After saving plots, the next section, 1.7, Common Problems, simply reassures us that when you're writing code, you're going to run into issues. You're going to misplace parentheses and quotes. You're going to get error messages, and this is just par for the course. It's part of the process of writing code. So don't be discouraged when that happens, and just pay close attention when it happens. Oftentimes you're going to get error messages coming back from R that are going to provide useful clues as to what the problem is. And just as an example of that, let's take this problematic code that they've provided and use this as an example for troubleshooting. So if we run this code, we get an error saying we cannot use the plus sign with a single argument. Did you accidentally put the plus sign on a new line? And that's exactly what's going on here. So if we look back at any of our previous examples, whenever we added on a new layer, we always had the plus sign at the end of the previous line before starting the new layer. But in this case, the way it's written, the plus sign is on the next line. So yeah, programming is very particular, and little syntax issues like that can really throw a wrench in your code. But we can just hit the up arrow and let's fix that problem. And there, we're back on track. Another common hiccup you might face as you're running lines of R code in the console is if you have a misplace or a missing parentheses, and I'll just demonstrate this. I'm going to remove that parentheses there and run this code. You'll notice that it didn't actually execute the code. And instead of showing me the greater than sign, which is what I usually see at my prompt when I'm ready to type in code, I'm seeing this plus sign here. And whenever we see this in the console, it means that R is essentially waiting for more code in order to complete this line. And in this case, it's waiting for it because we are missing that closing parentheses. So if this happens, if you run a line of code and you don't see the results immediately and you don't see the prompt, sometimes the best thing to do is just to start over. And the way you can do that is if you hit the escape key, that's going to get you back to your prompt. And then you can revisit that previous line that you wrote, fix any of the syntax issues you might have had, and then rerun your code until you get it correct. So all these little tips and tricks and learning to interpret error messages, they're all going to come with time. And as I mentioned a moment ago, it's all just part of the coding process. And even experienced programmers are routinely making these mistakes. And it's all just about how quickly you're able to identify the mistake and continue on. To wrap up this chapter, let's go through the summary and recap what we've learned so far. We've learned the basics of data visualization with ggplot2. We've learned that the essence of creating plots is mapping variables in our data to aesthetic properties like position, color, size, and shape. And then we also saw how we could add onto our plots layer by layer. We explored a sampling of commonly used plots such as scatter plots, bar charts, box plots. We learned how to visualize the distribution of both single variables as well as visualizing the relationship between two or more variables. And then finally, we learned how we could divide our plots into small subplots using faceting. As noted at the beginning of this video, the idea here was to get a taste of what we can do with visualization. We'll be digging more into it later in this book. But as for our immediate next steps, the next chapter is on workflow basics. And here we're going to rewind a little bit and take a closer look at some of the code syntax that we've encountered in this first chapter on data visualization. And that's just going to lay a solid foundation for the rest of the work we're going to be doing with R as we continue through this book.